Hello everyone. Okay, so this little video is about how to apply a unit tax to supply and demand using algebra. So this is in chapter 1 of that intermediate micro theory book, and the author of that book does something kind of weird, something I've never seen. He makes a distinction between an excise tax and a sales tax, and he attaches the excise tax to the supply curve, which is the way I've always seen it done and the way I've always taught it. But then he attaches the sales tax to the demand curve, which I've never seen done, but it is kind of interesting. So we'll go ahead and work this problem. I think it's problem number 2 or maybe problem 3 in that chapter, and we'll work it just like he intended. But really, for me, later on, after we go over this, it'll be okay with me if you always attach unit taxes, no matter which kind they are, if you always attach them to supply curves. But again, we're going to do it both ways because it is kind of interesting and I've never really seen it done this way before. Alright, so let me get my image out of the way and we can start. So this is a little problem that I just made up. We have a demand curve of 400 minus 3p and a supply curve of 100 plus 2p and a tax of $10. And then we want to know how to manipulate the supply and demand curves under the excise tax and under the sales tax. So under the excise tax, which is the way that if you ever had me for a microecon class before, it's the way you would have seen it done, we would attach the tax to the supply curve. So it would look something like this. You have your supply curve and then it just kind of shifts out this way, where the vertical distance between these two curves is the amount of the tax, in this case $10. And then we have to establish the new equation, the supply curve after the tax, the new equation. And since it's parallel to the old equation, the coefficient on p will be the same, but this number will be different. And thanks to that craziness that Alfred Marshall did, where he drew the supply and demand curves with p on the vertical axis, but then when he wrote out the equations he put q on the left side. Due to that kind of non-traditional way of doing that, we can't just add the $10, which is what you would do in an algebra class. We can't just add the $10 to this number here. One more time now, this number looks like the y-intercept, but it actually isn't. It turns out that's the x-intercept. So while you're tempted to just add 10 onto here and say that the QS tax is 110 plus 2p, that's not really what it is. Now you can work it out or ask me to do it in class, but there is a shortcut technique, and the technique is as follows. You take the tax, which is $10, you multiply it by the coefficient on p, which is 2, so that would be $10 times 2 is 20, and whatever that product is, that 20, you subtract it from the constant term, and that will give you the term that goes up here. So QS tax will be 80 plus 2p. One more time now. You take the tax, you multiply it by the coefficient on p, so 2 times 10 is 20. You subtract whatever that is from this number, so 100 minus 20 would be 80. Now let's see if that works out. The original equilibrium would be where quantity demanded equals quantity supplied from the original equations. And so we had the demand equation was 400 minus 3p, so I got 400. I'm going to subtract 100 from both sides, and then I'm going to add 3p to both sides, so I got 5p on the right side. I'm going to divide through by 5. I get an equilibrium price of 60. Did you get that? I hope so. Then we can find the equilibrium quantity by just setting the 60 into the demand equation. So 3 times 60 is 180, and I'm going to subtract that from 400. I get 220 for this number right here. I can check my work by sticking the $60 into the supply equation, so it would be 60 times 2, 60 times 2, and then add 100 to that, and I get 220, so that must be right. So this is our equilibrium before the tax, and then after the tax it should be 400 minus 80, and then again I'm going to divide through by 5, I get 64. So this number right here is 64. Now, for those of you who haven't seen this before, it looks a little bit counterintuitive because the tax was $10. So aren't you tempted to just say, well, gee, if the tax is $10, the price should have gone up by $10. But you can see that it didn't. It went up by something less than $10. So what exactly happened? Well, the customer came into the store, paid $64, and then the business had to give up $10 to the government, which puts them down here. Here's the $10. And so this number is 64 minus 10, or 54. Now, the way I designate these things is this is the original equilibrium price, and then this price up here, the $64, is the price consumers would pay when they come into the store, and this price down here is the price producers get. So in one sense, producers get all of this. They get the $64, but then they have to cough up the $10 to the government, so they're really, net of the tax, they really only get $54. A good discussion question about this kind of exercise is, why is it that producers absorbed part of the tax? Why didn't they just pass all of the tax off to consumers? It's a really good question. And the reason is, of course they would like to do that. So as they try to pass this tax off, what happens is consumers back up along their demand curve, and they resist the higher prices by consuming less. And as consumers purchase less, that forces producers to slide back along their supply curve until some kind of equilibrium is established. If you think about this, and maybe we should do one in class, if you picked a different kind of demand equation that was really, really steep, pick something like this, really, really steep, then when consumers attempted to resist the higher price, they wouldn't resist very much, and then if you had a demand curve that was really steep like that, it would turn out that consumers paid most of the tax. In this particular example, consumers really didn't pay most of it. They paid slightly less than half, because consumers paid this, right? We would say it like this: consumers pay the difference between the original price they used to pay, which was $60, and the new price they must now pay, which is $64. So consumers paid $4 of the tax times every unit that was sold, and we haven't calculated that. We should calculate what this number is right here, and the way to do that is just say, well, okay, the price was $64, so here's our demand equation. So 64 times 3, subtract that mess from 400, and I get 208. So this number is 208, right? So we say consumers paid $4 on every one times the number they bought, which was 208. So 208 times $4. Consumers paid $832 of the tax. Then, well, what did producers pay? Well, we say producers pay the difference between the price they used to get and the price that they now get after the tax. So for them, that's $6, right, from 54 up to 60. So producers paid $6 times the number of units that were sold. So in their case, it'd be 6 times 208. So producers paid $1,248. So in this example, producers pay a little bit more than consumers, and the total tax revenue generated can be found one of two ways. You can add up what producers and consumers paid. I get $2,080. So that's one way to do it. The other way to do it is to just recognize that this distance from here to here is the amount of the tax, which was $10, right? $10, and 208 units were sold. So $10 times 208 gives me, again, the 280 number. So either way. So you may have seen this in some other class. This is how I normally teach it, and this is how it's usually demonstrated in a microeconomic principles book. But your author here makes an interesting distinction by separating out what he called a sales tax and an excise tax. Okay, So this is where we were originally, and now we're going to put on the sales tax, and your author wants to attach the tax to the demand curve. So from that perspective, it would cause the demand curve to fall. That is, consumers would be less eager to buy this thing than before because they are burdened with the tax, right? So it would look like this. We'd get a new demand equation down here, and we would find it the same way we found the new supply curve before. That is, it will be parallel to the original demand curve, but it'll be lower where this vertical distance right here is the amount of the tax, and in this example the tax was $10. Again, thanks to Alfred Marshall, the algebra is a little bit clumsy, but you can work it out or ask me to do it in class. I'm happy to do it for you. Or you can memorize this little shortcut, and the shortcut goes, you take the tax, which in this case is $10, you multiply it by the coefficient on P, which in this case is 3, so 10 times 3 is 30, and you subtract that number from the constant term, so 400 minus 30 would be 370, so I get the new quantity demanded after the tax would be 370 minus 3P. Okay? So what's our new equilibrium? 370, we're going to subtract 100 from both sides. Alright, 270, and then we're going to divide that through by 5. So I get 54. So this number down here is 54. And remember that the amount of the tax was $10. So that means this price up here is 64. These numbers sound familiar to you? I hope so. And then this new equilibrium quantity, I bet, is 2080. But let's just work it out and see. So let's see, we're solving for this equilibrium right here. So I had a price of 54. I'm going to stick that price into this supply equation. So 54 times 2 plus 100. I get 208. 208. Now let's check our work and see. If I stick that $54 into the demand equation, this one over here, I get 54 times 3. It's negative, and I'm going to add that negative number to 370, and again I get 208, so it must be right. So in this case, everything is turned upside down a little bit. This is the price that consumers pay for the product, right? This is the price they pay for the product, but then consumers also have to pay the tax, so the consumers walk out the door paying this, just like they did before. This is the price consumers pay. But, you know, we're kind of splitting hairs here. So consumers paid $54 to the vendor, and then the vendor said, oh, by the way, there's a tax of $10. Please give me $10 more. So consumers paid that. The vendor's left with the $54 just like before, and everything else works out just like it did. This is the amount of the tax, because producers used to get $60 and now they only get $54, and this is the amount of the tax that consumers ended up absorbing, because consumers used to pay $60. Now they pay $54, but they also have to pay the tax, which moves them to $64. Alright, so this is how this problem is worked, and I hope you can do this on your own. There's one in the book for you to do, and if you get stuck, please ask me in class. So, good luck.